All right, so now we have a pretty clear definition on what is the optimal level of pollution and what's the optimal level of pollution reduction, right? And so we have basically two main categories of pollution control policies: command and control and market-based approach. And within that, you have two other subcategories we can see here. All right, so we'll go through one by one, although not in this order. Right, we want to do so. The order that we're going to do is first we start with technology base, and then a Pigouvian tax, and then an emission standard, and then a transferable permit. Okay, and as we talk about each of these, hopefully you can see it'll be clear why we will go in this order. Okay, and I'll just give you the punchline here. Right, the basic summary. On the pros and cons between command and control versus market based has to do with information. So if you have an industry where it is mostly homogeneous, meaning each of the firms is largely the same, right? They have the similar costs, they use a similar technology, right? They have similar size and location, etc. Then a command and control approach works very well. It is very efficient, it is very clear, and there's low monitoring costs. However, if you have an industry where it's heterogeneous, where the industry is they have very different cost structure, right? And that might be due to different technology, or it might due to location or the size of the companies. In those cases, the government or the regulatory agency are typically operating at a very limited amount of information, and monitoring might be very difficult. So therefore, a market-based approach will be more suitable. Okay, all right, so here we go. Oh, so first example is, let's talk about technology-based regulation. Okay, so this is, here's some links you can take a look at. I pulled this example from the EPA website, but but essentially, a technology-based regulation just means the government or the government agency decides what technology the industry are using to reduce the emission. Okay, so for example, following the Clean Air Act in 1975, the U.S. EPA required all new automobile to include a catalytic converter. Okay, now so this is a catalytic converter. It's a little piece of equipment between the engine's your engine and the exhaust pipe. Okay, what does it do? It takes some local harmful air pollutants like carbon monoxide and nitrous oxide, put it through this honeycomb, and comes out less harmful. Carbon dioxide and nitrogen is not a local pollutant, or it is a greenhouse gas, but the goal at the time was to reduce local air pollution. Okay, now is this the only way to reduce or to eliminate nitrous oxide and carbon monoxide? No, right? There are other technologies available. However, in a technology-based regulation, companies don't have the flexibility. The government decides that which technology each firm have to use. Okay, another example: each coal power plant needs to install this scrubber, right? It needs to install this scrubber to reduce sulfur dioxide. Okay, every coal power plant in the country have to use the same technology. Okay, now what are the pros? Well, what are the pros and cons here? All right, so one, the industry as a whole will adopt the best technology. Now I put best in quotes because best is determined by the regulatory agency. So EPA, they will hire engineers and scientists and economists, and try to figure out what is the best technology for the industry. Okay, so if the EPA, for example, has enough information and enough knowledge to make this decision, then we can say it will be the best technology. Okay. Now, although you want to be careful with that assumption, is because often the experts in the industry are not working in government, but instead they're working in the industry, right? And second, one of the pros could be that it will lower the cost in technology. So let's take the catalytic converter for example, right? And now you have increased the supply of catalytic converter because you force everybody to adopt the same technology. So the technology becomes more widely available. The market doesn't have to service and supply 10 different technologies. Low enforcement and monitoring costs. Now this is the main the main reason why, or the main benefit of a technology-based regulation, right? So for those of you with automobile, every few years you have to take it to get a smog check, right? And you can take it across the nation, or at least in California, across California, to thousands of different smog check stations, and you don't have to worry about matching the technology with your car because it is uniform and it is relatively cheap, right? It is pretty cheap because anyone with some capital, they can invest into opening a smog station, right? And they can do that easily, a low barrier to entry because the technology is uniform. Okay, and so there's a low enforcement in the monitoring cost there. Monitoring costs. So the example, for example, like a power plant with their when they install a scrubber, right? If the company, or sorry, if the EPA were to monitor the emission directly, that is very difficult because there's a lot of potential for cheating, right? Because the power plant, the emission varies greatly as they operate, and so instead of monitoring based on emission, the EPA could monitor based on technology. Therefore, the EPA can just become an expert of the technology, so they can make sure that when they go check the factory, they know that the technology works. All right, so enforcement and monitoring is the main benefit of a technology-based regulation. All right, now what are the cons? Well, less incentive for innovation. Suppose that I can develop a new technology that is superior and cheaper than the catalytic converter. Now, will I spend the millions of dollars into research and development? No, because it's too much risk, right? If I spend the money, develop this technology, but if the EPA decided that it's not going to adopt the technology, then I simply lose all that money. Right? So there's no incentive for innovation, and so when you have a technology based regulated industry, the innovation now requires on the public sector. Lack of flexibility, right? So for example, what if some firms in the industry is able to reduce emission at a much cheaper but less costly method technology, right? So they don't have that flexibility. Now, for industries such as the power plant, coal power plant, or the automobile industry, the technology is pretty uniform, so we don't really have that problem. But for a lot of other industries, right, you might have that issue, and where allowing some flexibility will generate more cost effectiveness. Now, when we said lower cost in technology, but we could also potentially create a monopoly for a specific technology that the EPA have adopted, and that monopolistic power could increase costs. Could increase costs instead. All right. Now, here's the main con. It is unlikely to be cost efficient because, again, you're relying on the EPA or the regulatory agency to decide what is the cheapest, what is the most cost effective technology, right? And that is not that is most likely not the case, right? And it is unlikely in most industries anyway that the most cost-effective method to reduce emission is the same for everybody. Okay, but finally, with the technology-based regulation, it's hard to meet specific targets. Right? Now we know that if we implement a particular technology, emission overall will decrease. We just don't really have a control over by how much. Okay, so the ultimate question: does the technology-based approach meet the equal marginal principle? A short answer is probably, most likely not. Okay. All right. So next, let's compare this to a Pigrouvian tax.